Hi, this is Professor Fernandez, and we are working here on Lesson 3, Video 2. The topic is finding the domain of rational functions, and this is example B8 from Calculus Simplified. Okay, so the idea for this video is to give you some exposure to how to find the domain of rational functions, which are functions defined as a polynomial divided by a polynomial. We in previous videos have worked on finding the domain in general as a sort of general concept, and so the point of this video is to apply that concept to some functions which can get kind of complicated, but also when it boils down to it uses a lot of the factoring techniques and strategies that we talked about in earlier videos. One particular video that you might want to revisit, this is video 3.2, which talked about factoring polynomials. So talked about factoring using grouping and also just looking at the different terms in the polynomial and trying to find greatest common factors and pulling those out. Okay, so let's talk about these first two examples here. So the first one on the left, these are both rational functions. Notice it's polynomial divided by polynomial. When you want to find the domain of a rational function, we're looking for the places where the denominator is 0. And then the domain has to exclude all of that. Okay, so that's the first step. There might be other stuff going on in the function, but because it's polynomial divided by polynomial, really it's just excluding those places where the domain is not equal to 0. If the functions were more complicated, for example, if it was the square root of x divided by x minus 1, well, this wouldn't be a polynomial anymore because the square root of x is not a polynomial. So part of the embedding here of what's being asked is being able to identify what is a polynomial, what is not a polynomial, which goes back to some of the earlier work and videos that we have worked on. Okay, so we have an honest-to-goodness rational function here. We want to then figure out where the denominator is 0 and exclude that from the domain. This one is fairly straightforward. Denominator of x minus 1, we set this equal to 0. Solve for x, we get x equals 1. So the domain, going back again to review some of those different ways of expressing the domain, you could write it out. You could say all real numbers except x equals 1. Could do that. You could do an interval notation. So all real numbers would be this, okay, but that includes x equals 1. So we are going to chop it up. We're going to get to 1. We're going to exclude it, right, parentheses, and then we're going to union, basically add in the rest of the number line, right, from 1 to infinity, excluding the 1. Okay, so this is another way to write the domain. And any one of these, like I said, in my class works well to express what the domain is in this example. So that's it for this rational function. There's really not a lot going on in the denominator. So now let's look at part B here. This is a much more involved rational function. Again, we can classify it as such. This is a cubic polynomial. This is a quartic polynomial, so this is a ratio of polynomials, so rational function, check. We want to find the domain, so we're going to look at the denominator, set this equal to 0, and then figure out what those points are that need to be excluded from the real line to yield our domain. Okay, so notice if you go back to this video, I had talked about one of the almost tip-offs, if you will, but not really. You kind of want to have it in your mind somewhere. When you have a polynomial that has four terms in it, you might want to think about factoring by grouping. Okay, so this is certainly something that's going to come up here. The first thing you might want to try though is, if you go this way, you might want to say, okay, this one has an x cubed in it. If I factor that, I get x plus 1. Okay, what about this one? So this one has a minus 4 in both sides, and it also has an x. So let's factor out a minus 4x. Okay. That will leave me with an x here and then a plus 1 there. And look how nicely this has factored out. Okay, so we now can see that each one of these terms has an x plus 1 in it. If we factor that out, what is left? Well, what's left is x cubed minus 4x. So x cubed minus 4x. Great. So this polynomial has factored nicely into the product of x plus 1 and x cubed minus 4x. Notice though, as we had done over here in this video, there's still a little bit more that we can do, and we definitely want to do it here because we want to find where this polynomial is 0 to help us figure out the domain. You might have seen this already, x cubed minus 4x. Both of these terms have an x in them. So I'm going to factor out that x. and what's left here is x squared minus 4. Okay, and then you can see this is the example that keeps on giving, right? We could go further. This is a difference of squares, x squared minus 2 squared, which can be factored even further. You don't have to do this last step, but part of doing these examples and exercises is to remember and go back to previous content you've learned, in this case factoring, so it helps you solidify that information. So if I factor this, remember a difference of squares factors into x minus a, whatever the a is, in this case it's 2, and then x plus a. So that is what goes in here. Okay, and I'll show you in a minute why you wouldn't have had to, you didn't have to do this to figure out the domain, but it just makes it a little easier, because now if I set this equal to 0, right, the original thing we wanted to do, we can just read off what the solutions are. X is 0, so that's one of them. X plus 1 is 0, so that tells me that x is negative 1. And then x minus 2 is 0. That tells me that x is 2. And then x plus 2 is 0. That tells me that x equals negative 2. So these are the 4 x values that we want to exclude from the real line to give us our domain. So I'm just going to write down the domain in interval form here to give you some of that practice. So we're going to start all the way at negative infinity, and then we're going to go to the leftmost number on our number line, right? So here's 0. So the leftmost number is this one, negative 2. So we go there, and then we're going to start from then negative 2 and go to the next one, which is that one, negative 1. Okay, and then we're going to start at negative 1 and then go to the next one, which is 0. And then start at 0 and go to the next one, which is 2. And then start at 2 and go off to infinity. So you can see this is a very long-winded way of saying, as I normally write this, we wrote over here in English, all real numbers except for these 4, right? And this is the interval notation way of writing that. All right, let me end the video by going back here and saying, what if you had not done this last step, this factoring by difference of squares? What if you had just gotten here, set it equal to 0 at this point? Well, this is the first 2 terms are the same as here. So you would have gotten the same 2 exclusions here, x equals 0, x equals negative 1. Great. But if you had not factored in difference of squares, you would be left solving this. Okay, great. So how do we solve that? Well, you could, if you did not factor using difference of squares, move this over and set it as x squared equals 4. In a previous video, specifically video 1.3, I talked about solving exactly this type of quadratic equation. It seems silly, right? Because in a sense, this is one of the first equations you probably learned how to solve in algebra. And what you might do again is you might take the square root of both sides and you say, oh, x equals, and this is where, it gets a little tricky. If you just say x equals 2, because the square root of 4 is 2, see this video why I'm, telling you that and not saying plus or minus 2. If you just did 2 here, you will miss a solution. You'll miss the negative 2 solution. Okay. So long story short, now that we've talked about various forms of factoring in the previous videos, some of those I mentioned up here for factoring. At this point, when you see x squared minus 4, I recommend that you use difference of squares factoring, right? So you do what's down here. That way you don't have to remember and potentially incorrectly derive some of the solutions when you get to something like x squared equals some number, right? And maybe you'll miss a solution. So you won't miss the solution if you factor using a difference of squares, right? As we did down here, the setting equal to 0 part will give you each factor, which themselves will lead to the solutions. Okay, so that's it for this video. This is finding the domain of rational functions. And last little thing I'll point out is that I can't stress enough how important it is that you figure out that you're actually dealing with a rational function before you apply what we did in this video. As we said in the beginning, if something even as small as this changes how you find the domain. And just to give you the answer, what would I do here? Well, I want the denominator to not be 0. So great, I have to exclude 1. But then over here, at least in a single variable calculus class, we don't want negatives under the square root. We don't want to take the square root of like negative 4, for example. So we would want x to be greater than or equal to 0. And we allow x equals 0 because the square root of 0 is 0, and it's in the numerator. Okay, so now the domain would change. We want to exclude 1, and we also want to exclude all the negative numbers, right? Notice how the answer changed, right? So this is no longer the correct answer for this example. Why? Because this boxed thing is not a rational function anymore. Okay, so in future videos, we will get back to this notion of finding domain of functions that are different. They're not rational functions. They're not polynomials. They don't fit neatly into one category. They're combinations. But again, for this video, finding the domain of rational functions, make sure you're dealing with a rational function before you go ahead and apply this strategy for finding its domain.